Hello everyone, welcome back to Math with Allison. Today we're continuing our series on limits. If you haven't already, make sure to check out some of my past videos. I have them linked here. Click that little I in the corner and it'll get you there. Otherwise, we're talking about e to the power of x and log of x and what those look like with limits. So let's go ahead and dive into it. So question of the day, what do these functions look like? First, on this first graph here, we have f of x equals e to the power of x. This is an exponential function, and if we remember, e is actually equal to 2.71. Lots of more numbers, but that's a good estimation. So as x goes to infinity, our graph shoots up because it grows really quickly. When x is going to negative infinity, our function decreases, gets really, really small, and gets really, really close to zero, but it never quite hits it. Let's go ahead and look at log of x. I have that graph right here. So log of x, as x goes to infinity, it still grows, but it grows at a much slower rate. As x goes to negative infinity, that function doesn't even exist because you can't take the log of a negative number. So actually what we look at is x equals 0. And at x equals 0, we can see our function shoots down. It goes down to negative infinity. So let's look at both of these on the same graph. Alrighty, so let's go ahead and look at e to the x first. I always suggest trying direct substitution, so if we have the limit as x approaches a of e to the x, just try plugging in whatever that value of a is. It's just going to be a number, right? Because e is just a number. Now, let's look at the limit as x approaches negative infinity. First, I want us to just try a number. Let's try x is equal to negative 10,000. When I plug that in, I get e to the negative 1,000. Which is equal to 1 over e to the 1,000. Really, e to the 1,000 is just going to be some really big number, so I'm just going to write 1 over big. 1 over big, as big gets bigger and bigger, goes to 0. And so this limit actually is equal to 0. I want us to see it in a different way, so let's take the limit as x approaches positive infinity, but I'm going to change my function to e to the negative x. So I'm going to plug in another value. Let's plug in x is equal to positive 1,000. When I plug that in, I get e to the negative 1,000 again, and I can see I get the same value, 1 over e to the 1,000, which is just 1 over big. So e to the negative x can be rewritten as 1 over e to the x, which behaves really similarly to the limit as x approaches infinity to 1 over x. It's just 1 over big, and 1 over big goes to 0. So those are two different ways you can think about it, right? Let's go ahead and take a look at the limit as x approaches infinity. Here, if I were to try direct substitution, we have x is equal to 1,000. E to the 1,000 is some big number. And so this one just grows like crazy. It goes to infinity. So now that's e to the x. Let's go ahead and look at log of x. Notice, like we pointed out before, we cannot take the log of a negative number. So we don't even exist in this quadrant. It doesn't happen. So we don't really take the limit as x approaches negative infinity. We look at what happens at 0. So let's go ahead and look at these different methods. First, similarly to e to the x, if we have the limit as x approaches some value a, just try direct substitution. Just try to plug that in. But there's some values that make it difficult to plug in, right? So like we talked about before, if we try to take a negative number, it doesn't exist. The function, it just like can't happen. And so we would write this limit does not exist. But we can take a look at the limit as x approaches infinity. So I want us to look at the table method to really see what's happening here. A little reminder right here, we have log base 10 of x equals y can be rewritten as 10 to the power of y equals x. And I'm actually going to use this in the table. So I already have these written out here in the table. I have my x values. I have it rewritten in my exponential form. And we need to figure out what exponent, what value of y makes these statements true. So if we look at our first one right here, 10 to the power of y needs to equal 1. So that means my exponent has to be 0 because 10 raised to the power of 0 equals 1. Let's look at 10. So if x equals 10, 10 to the power of y equals 10. So then my y value has to equal 1. For the exact same reason, 10 to the power of 1 is equal to 10. So we just keep going with that pattern. So it still grows. It's going to grow forever and forever. However, it's going to grow at a really slow rate. So this goes off to infinity. And you can check that with the graph, right? So now let's go ahead and take a look at the limit as x approaches 0 of log of x. We're going to do a very similar thing, but instead we're going to decrease in our x value and get really, really close to 0. So for the exact same reason, 10 to the power of 0 is equal to 1. Now let's take 1/10. 10 to the power of something is equal to 1 over 10. My exponent is actually going to be -1, and that's because 10 to the -1 is equal to 1 over 10. So we're going to continue with that pattern. I get -2, -3, and then 1 over 1 million, our y value is going to be -6. So again, it grows, it's decreasing, but it's still decreasing at a pretty slow rate. So this goes down to negative infinity. And we can see that in the graph, right? So that's how those two functions behave. Let's go ahead and look at some other fun examples. First, we have the limit as x approaches positive infinity of e to the power of 1 over x. So if we remember, the limit as x approaches infinity of 1 over x is equal to 0. So that means our exponent is going to go to 0. And using substitution, we get e to the power of 0. And anything raised to the power of 0 is just equal to 1. So this entire limit is equal to 1. Let's go ahead and do the same thing. So again, this inside 1 over x is going to go to 0. So using direct substitution is actually not going to help us right now because log of 0 does not exist. But that doesn't mean our limit does not exist. What actually happens is this behaves really similarly to the limit as x approaches 0 of log of x. Because this inside right here that I just scribbled under, that is approaching 0. It's not equal to 0, it's approaching 0. So that means this is equal to negative infinity. So I'm going to rewrite that whole thing. So that is all I have for us today on e to the x and log of x and how they work with limits. If you enjoyed this video, please leave a thumbs up and comment other videos, other topics, other problems that you'd like to see done. Thank you so much for watching.